Hello students. So today we are going to see the derivatives of inverse trigonometric functions. So let's see that how to find out the derivative of inverse trigonometric functions. So derivative of inverse trigonometric function is also very simple topic if you know the derivative of trigonometric functions. So I hope you are all aware of the derivative of trigonometric functions. And with the help of that only we calculate the derivative of inverse trigonometric function. So let's just recap the derivative of trigonometric function. So you know that d by dx of sin x, we have cos x, derivative of cos x is going to give you minus of sin x. Okay. Similarly, d by dx of tan x you get as sec square x, d by dx of cot x you get as minus cosec square x, then d by dx of sec x we have sec x tan x, and d by dx of cosec x is going to be minus cosec x into cot x. Okay, so these are the derivative of the trigonometric functions, and I hope these are also not only learned in this class, you are already using it in physics in so many application part. Okay, so with the help of that, how we can find out the derivative of inverse trigonometric functions? You can see that. One more thing, if you are not able to remember this formula, sometime you forget, so you write it again and again, so it will be easily learned. And this plus minus confusion is there, so here you can see those trigonometric function which are starting with co, means co. So those functions are having the derivative in negatives, minus sin x, minus cosec square x, minus cosec x, cot x. So only cos, cot and cosec, they three are the negative. Other three, sin, tan, sec is positive. Okay, so by this way some pattern you can create in the mind to learn it. Then we are going to see that what will be the derivative of inverse trigonometric function. So for the derivative of inverse trigonometric function, we use the previous trigonometric functions only. For example, if we have to find out the derivative of sin inverse x, so it can be calculated with the help of trigonometric functions. So let y is equal to sin inverse x, so we can write it down as sin y is equal to x. Now differentiate with respect to x both sides. So on differentiating with respect to x, what we get, this sin y will give us cos y, because we have just seen the formula, sin x derivative is cos x, so here sin y derivative will be cos y, and dy by dx also will be multiplied by the chain rule because it is not x, it is variable y. Here this side derivative of x with respect to x is going to be 1. Now dy by dx is going to be 1 upon cos y. This cos y you can write down as under root 1 minus sin square y. And you know that this sin y already here as x, so that you can substitute here in terms of x the function which we get as output of dy by dx, here 1 upon under root 1 minus x square. This is your derivative of sin inverse x. Okay, so this way we can find out the derivative of other functions too which are in inverse form, but we can convert them into the simple trigonometric function and then we can find out their derivative easily. So just like sine inverse x, we can also find out cos inverse x exactly in the same manner. Only change comes that here your sine y will be coming, which you convert into 1 minus cos square y, and then cos x value you substitute. Since cos y derivative will be minus sine y, that's why negative comes into that. So the similar kind of formula comes for the derivative of cos inverse x, and that will be exactly same as sine, just only minus sine will be present here. So this is the derivative of cos inverse x, and I hope this will be also going to be simple to understand how this derivative is going to be coming. So exactly in the similar manner as you have done the sine inverse x derivative, in the same process you can find out the derivative of cos inverse x. Now let's see the derivative of tan inverse x. So we have to find out the derivative of tan inverse x. So how to find out derivative of tan inverse x? In the same process as we have found the sine inverse x. So let y is equal to tan inverse x. We can write it down, tan y is equal to x, and differentiate both sides with respect to x. So we get tan y derivative, already you are aware, so it will be giving you sec square y. This side you will be getting one more thing here will be there in the product, that will be dy by dx, and then this side derivative of x is going to be 1. Then dy by dx you can write as 1 upon sec square y. Now you know the identity, sec square y can be written as in terms of tan as 1 plus tan square y. Okay, and tan y is x here, so which you can substitute. So it is going to give you 1 upon 1 plus x square, and this is the derivative of tan inverse x. So in the same manner you can also calculate the derivative of cot inverse x, and that comes exactly in the same way, and also the expression also comes exactly same. Only change is there is negative of this minus 1 upon 1 plus x square. So as you have just derived the formula for derivative of tan inverse x, in the same manner you can also derive the formula for cot inverse x derivative. Now let's see the derivative of sec inverse x. If we have to find out the derivative of sec inverse x, so we have to follow the same approach as we have followed in sine inverse x, tan inverse x and all. So here we are going to choose, let this function sec inverse x is equal to y. So that means your x is going to be sec y. Differentiating both sides with respect to x, so we will be getting, on differentiating with respect to x, we will be getting here 1, and this side we get sec y derivative. You know that it is sec y tan y and dy by dx, okay, by the chain rule. Now what dy by dx can be expressed as 1 upon sec y into tan y. Okay, now you have to see one more important thing. Okay, now very important thing here, you have to notice that since y is representing sec inverse x function whose range is situated between 0 to pi, in which your pi by 2 is not included except pi by 2. That means the interval for range is you can say that is between 0 to pi by 2 union pi by 2 to pi. That means your first quadrant and second quadrant, in which your pi by 2 is not included. That's why here open intervals are there. In both quadrant the y belongs, that means range of sec inverse x is there. And so what will be your sec y in the first quadrant? That will be positive, and tan y, that is also going to be positive, because in first quadrant you know that sec and tan both are positive for the theta which is in first quadrant. Similarly, in the second quadrant your sec y is going to be negative, that means less than 0, and tan y is also going to be negative. So that means the product of these two in the first quadrant is also going to be always positive. In the second quadrant also both are negative, so their product will be again positive. That means whether both are positive or both are negative, their product is going to be always positive. That means this product sec y into tan y will be always positive. That's why when we substitute the value of sec y as x, so here first you convert this function as 1 upon sec y. This tan you can write as under root sec square y minus 1, because using the identity, so we can write tan y as under root sec square y minus 1. Now when you substitute the value of sec y as x, so this whole function what we are getting, dy by dx is equal to 1 upon x under root x square minus 1. Since I have discussed that sec and tan product will be always positive whether it's a first quadrant or whether it's third quadrant, that's why x cannot be negative, their product will be always positive. That's why we use the mod here. Here already square is there, so automatically it will be positive always, so there is no need to apply the mod on this x. So that's why the derivative of sec inverse x which we get in this form of x, that is this 1 upon mod of x into under root x square minus 1. Okay, so this is your derivative of sec inverse x. In the same manner we can also find out the derivative of cos inverse x. Exactly same approach will be there, only the difference will be there, here negative comes into that. So your derivative of cosec inverse x is going to be minus 1 upon mod of x into under root x square minus 1. So this is the derivative of cos inverse x. So this way we can find all the derivatives of entire inverse trigonometric function with the help of trigonometric functions. So rest of the things are the application of these formula, and as many problems you attempt, that much clarity you get. So I hope it was clear to all those which has been discussed. So thank you all.